All right, hello everybody, this is Miss Pie. Um, I'm doing this video recording on late Sunday night and before we do any of the application problems, and I'm going to go ahead and post it as soon as I get done. So if you watch this early, there's going to be some application problems that you're going to be totally lost on, or you may be totally lost on. So I would suggest you either wait until Wednesday to watch this video, or just watch it again on Wednesday. Hopefully the application problems will be clearer. And also, please take notes and fill out an index card because you can use your index card on the test. All right, so let's go ahead and get started. Um, First type of question you're going to get is you're going to need to figure out what type of functions or what type of graphs, what type of functions create these types of graphs, whatever. Anyway, so we've got 4 different graphs, and of course everybody's going to have a different version of the test. So, one of you might get a graph that looks like this or this or this or this, or one that's completely different from all of these, but you'll still need to know whether it's exponential, logarithmic, a logarithm function, a logistic function, or a power function. So guys, those are the 4 types of functions that we've been working with this so far. And I will tell you, you're going to have you're going to have the equations on the test too. So that's one way you can tell what type of function you have. Okay, so let's first talk about I guess we can go through this in order that we've studied them. So the first ones we looked at were power functions. And with power functions, your x is the base number, and it was raised to some power. So this one right here was your, hold on, let me see if I can get rid of that power function. Yeah. So, and remember, power functions can be any type of power. So if you have like say we have the graph, x to the 3rd power, then your graph is going to look something like that, right? And it's still a power function because your base number is x and you're raised to some power of some sort. So power functions just means your x is the base number and you have some exponent. All right, the next one that we studied were exponential, and that's when you have a base number and your x, or your variable, is the exponent. So this is the next one, and it's exponential. And then the third one we looked at was a logarithm function, and you can have a log base 2, or even if it was a natural log, it could also be in the form of natural log ln of some number or something, so maybe 2x or x or whatever. Okay, so you can have a natural log or a logarithm. They're both going to be a logarithmic graph, either type of those equations. And then the last one, this is one that we will look at this week on the application problems. It's called logistic, and this is what the graph looks like. So if you're watching this Monday or Tuesday, you may be totally lost on what a logistic function looks like. But if you notice, we have our e value here, and we'll see a couple of application problems that use logistic functions. Okay, so let's go ahead and move on. You'll have a problem where you have to basically solve for x. In this one, if you notice, you have your variable x on both sides of the equation, and I will tell you, your college professors are going to love to give you these types of problems on tests, on quizzes, on all sorts of places. So I'm hoping that you will get very familiar with this. Basically, what you want to do is you want to change this exponential function into a logarithmic function, but it's kind of problematic because you have exponents on both sides of the equal sign, and you have a variable on both sides in both exponents. Okay, so a couple things that you need to do is decide what is going to be your base number, what is going to be your x, and what's going to be your y. So in this case, make this fraction into your base number, okay? And then this over here that's kind of on its own, I guess you could say, is just going to equal y. So it's not just the 2 minus x is y or just the 7 is y. The whole thing is going to be your y value, okay? And then that just leaves x, your exponent over here is just going to be your x, okay? So you can do it the other way as well. You can have this 7 raised to the 2 minus x power be x, or, yeah, sorry. You can have your base number be 7, your 2 minus x be your x, and the, let's see, yeah, and then this part over here be your y, sorry. And in some cases, it really doesn't matter which side you choose, but I will tell you that anytime you have anything extra in your variables up here, like we have the 2 minus x, it's going to be a little bit more problematic to have this 2 minus x in a log. Okay, so one thing that to remember, the more basic exponent, you want to leave that as your x. Okay, hopefully that will help you figure out which side to work with. All right, so let's go ahead and move on. So we have, this is our b, this is our y, and x is x. So then we're going to change our formula into a logarithm. So we're going to change from an exponential function to a logarithmic function. And when we replace, this is where your b and your y and your x go. Well, when we replace the b, y, and x with these things, then we get this. We get log base of 3/5 of 7 raised to the power of 2 minus x. And then that is going to equal x. Okay, so when we do that, we know that with logarithm functions, if this number here has an exponent, that exponent can be moved up front and you're multiplying then. Okay, so now we just have this. Okay, and in your calculator, if you wanted to, you could plug in log 5 with base number 5 over 3, 3 over 5 of 7 and get a calculation. And you would get negative 3.809, and it keeps on going forever. I'm going to abbreviate that. So it's approximately negative 3.809. All right, so that is what this thing equals. Okay, so now I want to simplify as much as I can, and I'm going to go ahead and I have this, I'm going to go ahead and distribute it. Okay, and then when I distribute it, I get negative 7.619 because I multiply by 2. And then I have a negative and a minus, so this becomes positive. And then from here, you just have to basically solve for x. So I'm going to subtract this from both sides of the equation, and I get this. And then I'm going to divide by negative 2.809, and I find that x is approximately 2.7. Okay, this is a problem that I have on the test. I have not changed a whole heck of a lot. I will change some of the numbers with each version of the test. These numbers are going to change, but the basic pattern is all going to be the same. So you'll have a fraction here raised to the x power, and then you'll have a base number raised to some equation. It might be 2 minus x, it might be 2 plus x, it might be 5 minus x or something like that, okay? So you're going to have the very, very similar equation to solve for x. Same basic pattern on the methodology on how you solve for x, but you'll just be dealing with different numbers. So if you watch this review and you take really good notes on this problem, you should be fine when you get this problem on the test. All right, so now this is one of the application problems we're going to look at on Monday and possibly Tuesday, depending on how fast we get through this. And we have bacteria that is growing in a batch of yogurt, and we have a logistic function that models the behavior or the growth of the bacteria. Okay, and how much bacteria, so with this type of question, with this scenario, you have a couple questions you need to answer. And I think right here it says 6 questions. I went ahead and reduced that number of questions to just 3, I believe. I'll have to look at it. All right, so let's look at the question. So how much bacteria is initially in the batch? Well, when you're looking at that, your t, or your variable, or t or x, is going to be your time. Okay, so initially time starts at 0. So if you plug in a 0 for your x, just type this in the calculator. You find that the initial amount of bacteria is approximately 155.8. Let's say 156, I don't know, pieces of bacteria. Is it called a piece? I don't know. Anyway, um, so that's our initial amount of bacteria. Let me see, what is this? Oh, yeah. And let's say you didn't feel like plugging or calculating that out on the regular calculator screen. You can go ahead and graph your equation. Pull up the table. When x is 0, guess what? You get 155.84 units of bacteria. Okay, so either one, you can either calculate it or you could graph it and pull up the table. Now the next question was, what is the maximum amount of bacteria that can be present in a batch of yogurt? Well, I will go over this probably tomorrow. Sorry, you're probably watching this on Wednesday, so I went over this last Monday. Whatever. I don't know. It's kind of weird videotaping this ahead of actually teaching you the material. Okay, well, let me tell you, or remind you, I guess, about logistic equations. Whatever you have in your numerator, that's going to be your limit, or the maximum amount of bacteria that you can have in your yogurt. So if you look at your graph, you can see that it's approaching this number. Well, let's say we weren't sure where the limit was. So maybe we want to, I don't know, you could maybe calculate this and put in a huge number for x. Well, it doesn't matter what number you put in for x, you're never going to have more than 1,200 units of bacteria. And you can also pull up your table. And on my table, I pulled it up and just had it, or I was at like 23 for my time, and I had this table step to be increments of 100. So you notice that when I'm at 23 hours, I have 1,199.99999 and so on units of bacteria. Okay, and it doesn't matter how much bigger. See here now, I'm at 323. I'm still only at 1,200. Excuse me. Okay, so if you remember about the numerator, you don't have to do all that extra stuff with the graph. Just look at your number in your numerator, and that is going to be your limit. Okay, so the last question we have is, as the amount of bacteria, here, let me move this graph. So as the amount of bacteria in the yogurt increases, the yogurt becomes tartar. Miss Pie likes the flavor of the yogurt when there is approximately 750 units of bacteria present in the batch. How many hours should Mrs. Pie process the yogurt to get the desired flavor? Okay, so this is kind of an interesting question, and I'm going to pull up another. It's going to take a lot of space to show you the answer and show you how to get this answer. Okay, so this is another one of those questions that college professors love to give you, and then they say, oh, by the way, you cannot use your graphing screen, or you can't use your graphing calculator. Well, when I actually had when I was taking college algebra and had this type of question, we didn't even have graphing calculators available. Well, I think they were available, but they were like $500. And believe me, college students cannot afford a $500 calculator. All right, so what we had to do is we had to set the equation equal to 750, and we had to solve for our x. Okay, most of you might think, oh my gosh, that is totally impossible to do. Well, it's not really. You just do the whole PEMDAS backwards and you solve for x. Okay, so we first take our denominator and multiply both sides by it. Okay, and then I could go ahead and distribute the 750 throughout this equation, or I could just divide both sides of my equation by 750. I like to do the more simple things, and so all I did was, I divided both sides by 750. Okay, so now I have this. Well, I want to get rid of the 1, and I want to get rid of the 6.7 so that I can have my e raised to this power all by itself. So I'm going to go ahead and do that, And when I do, first I have to subtract by 1, so that's this. Then I'm going to divide by 6.7 because I'm multiplying here. Dividing is the opposite of multiplying, so I'm dividing. So now I have this equation, and yes, it does look super crazy. But now I just need to get rid of my e value, okay? And if you remember the properties of logarithms and natural logs, if I want to get rid of e, I'm going to use my inverse, which is my natural log. So I'm going to apply the natural log to both sides of the equation. So I'll have natural log of e of all this stuff equals the natural log of all this stuff. So remember, whatever you do to one side, you have to do to the other side. All right, so now right here, we've got this exponent here, and as you remember with logarithms, if you have exponents, you can put them up front and you're multiplying, okay? And the natural log of e cancels out. That's a 1, okay? So on this side of the equation now, all we have is negative 0.59 times x equals all of this stuff, okay? This is going to be a huge equation when we're done. Okay, so now I have that, and I want to go ahead and divide by my negative 0.59. Okay, so I do that, and I get x is going to equal all of this huge thing. Okay, so check out all the parentheses. I've got tons of parentheses. When you plug this into your calculator, be super, super, super careful. Make sure you have all the parentheses in the right spot. Make sure you have a fraction here and all that fun stuff. And I will tell you, be very careful. Make sure you go back and look at the equation after you type it in, because there's a lot of ways to mess up on this equation, okay? And honestly, I will tell you, I didn't even plug it into the calculator, because even though, yes, you can do that, there is a much easier way, because, hey, guys, guess what? You do have graphing calculators, and I have not banned them from my classroom. So all of this stuff that we just did, okay? If you had plugged this whole thing in your calculator screen, you would have gotten the value of 4.09. Okay, how do I know that? Well, because a much easier way to find that answer instead of going through all this long process is going ahead, graphing your equation. Let's see, you want to graph this equation right here in your f of 1 of x, so f of 1 of x. That's supposed to be a parenthesis, sorry guys. There we go. And then you're going to graph this in your f of 2 of x. Okay? And I've shown you guys how to do this before with lots of other types of equations. Guys, it does not matter what type of equation you have. Anytime you want to find x and they give you a y, you can do this. Okay? So I plug the original equation in for f of 1 of x, and then I plug this in for f of 2 of x, and then I just analyze the graph and find my intersecting point. Okay. The only time you're not going to want to do this is when your professor says, give me the exact answer. Okay. When he tells you to give him the exact answer, this right here would be your exact answer. You wouldn't even put, like, let's say you plugged this whole thing in the calculator and you got the answer was 4.098231 and whatever and whatever and whatever. I mean, you wouldn't even type in everything that you had on your calculator screen. If your professor says, what is the exact answer? This is what you would have on it. Now, because we are not in college, because we're still in high school, I will let you give me this answer, and you can find it either way, either by graphing both of these two equations and finding the intersecting point, or by doing all this long, drawn-out math. It's totally up to you. I'm kind of lazy, and with the time being as it is, usually in college you have like 2 hours, 3 hours to take a test. In high school you have, 45, 50 minutes. Go ahead and just do that to save yourselves time. All right, moving on. Okay, here's another application problem that we're going to look at this week. So the weight of a radioactive material in grams W over a period of weeks, T, is given in the table. So guess what? Create a scatter plot. We've done it a million times. And guys, the nice thing is this is a multiple choice test, so create a scatter plot and then check these equations and see which one fits the scatter plot the best, okay? So when you do that, and we've done this a lot, go ahead and do your, let's see, spreadsheet, okay? Fill it in, make sure you label your columns. And then last time that we did this, I showed you guys how to get a big graph or a big scatter plot. And the way you do that is after you pull up your spreadsheet or after you fill out the spreadsheet, go to Doc, go to Insert, and then Data and Statistics. It's going to give you this thing here, and you are going to want to click on this and to make it as X and click on this side to make it a Y. And then when you do that, you get this shape, okay? Now, the problem is that shape kind of looks like a linear function. I mean, I can basically draw a line there. Well, that's a terrible line. Let me see if I can make it a more linear line. Let me see, recognize it. There we go. So, I mean, I could create this linear equation, right? So then let's go back. Which one of these is a linear function? Well, hello, this one is, okay? So some of you might say, oh, since it looks like it's linear, let's choose this since this is a linear equation. And let's see, this is a exponential function. This is a power function, and this is another exponential function. So let's take the easy road, right? Well, guess what? This is the wrong equation, okay? How do I know that? Well, because I've gone ahead and analyzed the graph and created here, let me move these down. So we're back at the, not quick graph, we're back at the scatter plot, okay? So this is the graph and it looks kind of linear, so I want to analyze it. And instead of going to the regressions where they show you all the different types of formulas, I want to just plot the function and, whoop, hold on, let me pull it up. And I can do that over and over and over again. And each time I do that, I get a different graph, okay? Let me move these all up. So these are the 4 different equations that were on my multiple choice test. And you can see that even though this is my linear equation here, so even though it's a linear equation and this looks kind of linear, the equation that I have to choose from, the linear equation I can choose from, it's like totally off the charts, doesn't intersect hardly any of my points. Well, and then I had, let's see, this is a power function, and that kind of worked better. And then this was one of my exponential, no, this is also a power function, excuse me. So this is a power function and this is a power function. And then this is a exponential function. And this one is like totally wrong. It almost looks just like this. It may be a slight variation. So now it's between these two. Well, if you look at it, most of you will say, hey, guess what? This one by far looks the most accurate, and you would be right, okay? So you can do the process of elimination, check out all the different types of formulas, and I will tell you, on this example in the review, this is the equation that fit the best, okay? For some of your tests, this type of equation where it's a power function may fit the best, or a power function like this might fit better, okay? Just make sure you plug things in, check them out, see which graph is the most accurate graph, okay? So most of the time you can eyeball it. If you really need to see your R value, ask me during the test and I will tell you how to see your R value, okay? All right, moving on. Here's another application problem. I'm telling you, there's a lot of application problems in this unit. The number of your friends who see a particular video you post on Facebook, in terms of the number of hours since you first posted video, X is modeled by this function F. Okay, data for F is shown in the calculator screenshot. So this is your data, and you need to figure out which of these statements is false. Okay, F is best modeled with discrete data. Well, in this case, what does discrete data mean? Discrete data, remember, is where you have gaps and breaks. Okay, so let's see. Let's analyze what we have. let's see. This is the number of your friends who see a particular video. So I want to know how many of you guys have half a friend or a fourth of a friend. Okay. So discrete data means you have breaks, you have solid chunks. So if I had, if this was my x value, I have 1, 2, 3, 4. If I had a continuous line right here, that means I could have 1.5 friends right here, or 2.5 friends, or whatever. Okay. Well, I can't have half a friend. I know some friends are sometimes an occasional friends, but you still don't have half of a friend. So in this case, this statement is correct. It is best modeled with discrete data. Okay. F is an exponential function. Let's see. So I think I graphed this. Yes, I did. All right. So exponential. You know what? That kind of looks linear, but it could also be exponential as well. Particularly notice with your scale here for y, your increments are huge, but your scale for x are very, very small. So if the x and the y were both to scale, this graph would look, or the shape of this graph would look very, very different. Yeah, so that's why even though it looks linear, it is actually exponential, because with exponential, you're increasing very quickly or decreasing very quickly. And in this case, we are increasing incredibly fast. Somebody must be very, very popular. So I will tell you that, yes, this is an exponential function. So that one's correct. And it says the common ratio of the function value is 1.1. So let's check that out. So same graph, but now since I decided yes, it is exponential, I went ahead and pulled up the exponential function. You can go to menu and analyze and regression and click on this show exponential function. And guess what? Your common ratio, and for some of you, you might not understand what the common ratio is. It's basically your base number here, the 1.1. The common ratio of the function value is 1.1. So that one is correct, and I will tell you, most of you probably have figured out that I purposely skipped B. And in this, it says that you only have 25,340 friends on Facebook. Okay, so if you have 25,340 friends on Facebook, then how can 44,891 friends view the video, 6 hours after it's been posted? So obviously in this case, this problem is inaccurate, or this statement is false, okay? So again, multiple choice test, you will have the same type of scenario. You're going to probably have different numbers here, and you might have slightly different statements here, okay? So maybe yours says it is best modeled with continuous data, or maybe this says f is a power function or whatever, okay? So check the wording. I will probably change the wording a little bit. I might change some of the numbers here, a common ratio or the friends or whatever, okay? So there will be different versions of this type of question. All right, here's the last one. Oops, and I just realized I totally forgot to cover this up. So close your eyes for a second. Just kidding. So this question, it says solve for x. Let me just walk you through this real quick. So if you're going to solve for solve for x, let's see. You have log of base 2 of x plus log of base 2 of x minus 7 equals 3. Okay, first thing you want to do, because you have the same base numbers here, you can combine these two, and you can combine them by multiplying the x times x minus 7, and you get this. And now you want to convert this logarithm back into an exponential function, excuse me. So your base number here is 2 is going to be your b value. This here, this whole thing, is going to be your y, okay, and the 3 is your x. Okay, so when we move everything around, base number stays the same, stays in the same place, and you just switch these places and you drop the log. Okay, so we have base number of 2 raised to the third power equals x times x minus 7. Okay, go ahead and distribute the x, and 2 cubed is 8. Okay, so what I've done now is I distribute the x. So I have x squared here minus 7x, and then over here I have an 8. Well, I want to move all my numbers on the one side, so I get a negative 8 here equals 0. Go ahead and FOIL that, sorry, not FOIL, factor it. You get x minus 8 times x plus 1. Set both of these terms equal to 0. Okay, and solve for x. So now I get x can equal 8 or negative 1. Okay, so I should be done. It should be easy to say, hey, your answer is 8 and negative 1. But let me see just a second if I check this. No, I didn't. Oh, you know what I did over here. Go ahead and plug both of those back into your calculator, and guess what happens? Hold on, let me move everything over. So when you plug that into your calculator, if you plug 8 in for x, okay, you get 3. Voila. So 8 is definitely a keeper. So this one works, but when you plug in negative 1 for x here, you get log base 2 of negative 1 plus log base 2 of negative 1 minus 7 equals error, no unreal calculation. Okay, here's the reason why you get an error. Anytime, and I don't know if I've covered this yet, but hopefully I'll remember to tell you guys tomorrow or Monday or Tuesday or Wednesday. Anyway, sorry. Anytime you have a negative number here, you're going to get this error message. You cannot ever have a log. Doesn't matter what your base number is here. You cannot have a log of a negative number here, okay? So watch those. When you have this problem, check both of your answers. If you have 2 answers, check both of them. If you only have one answer, check that answer, because even though you only have one answer, it still may not actually work. This is another type of problem that your college professors are going to love to throw at you. And sometimes you'll have more than one answer. Sometimes both of them will work. Sometimes none of them will work. Sometimes only one of them will work. All right, let's move on. Another application problem. I really hope we have time to get through to this activity. I'm hoping to do a vampire activity Wednesday because it's a lot of fun. All right, so you have vampires invading Killeen, Texas, and they create new vampires unimpeded. A model for the population of the vampires in terms of time and days T is this equation, okay? So again, we have a logistic application problem, and then I think my first test that I had this problem had like 3 or 4 questions all based on this equation. I think on this one you only have 1. So in this case, how many vampires initially invaded Killeen? Again, your time when something initially happens is 0. Plug in 0 for here. Type it into your calculator to calculate your answer, and you get that there were 5 vampires that initially invaded Killeen. All right, this one's a fairly easy question, and I will tell you, I did not realize until about an hour ago that of all the other questions that I could have used, notice that this is the one that asks about initial values, and there was another application problem that I asked about initial values too. Hold on, yeah. The yogurt one, I asked about the initial value. Remember this one, how much bacteria is in the initial batch? Okay, same process. It doesn't matter what the scenario is, doesn't matter what the numbers are. If you're looking for your initial value, then your x is 0, and you can just calculate it. It's pretty easy. All right, so that one is kind of a gimme question. I'm hoping nobody gets it wrong. That should be a very easy question to answer. All right, just a couple more questions. Let me see. All right, so you have this graph, and it's a graph of a function that represents temperature of an object U in terms of the number of minutes T that it has been removed from the heat source according to Newton's law of cooling. We'll go over this application formula probably Monday or Tuesday. All right, so now which of the following statements is definitely false based upon the given information, okay? So keyword there is definitely. And in this case, let's go ahead and take these one by one. And yes, I know it's going to be a multiple choice test, but let's see if you can figure out what the correct answer is that would make it true, okay? So in this case, one of the statements is the initial value of u is blank, okay? So what's the initial value? Remember, your time is 0 for your initial value. If you look at your tick marks, you have 20, 40, 60, 80, and 100. So in this case, your initial value should be 100, okay? So that one is true. If there's a vertical asymptote, it occurs at blank, okay? So vertical asymptotes go up and down. So this would be what? Maybe x is 0 and t is 0. Okay, so notice I use t instead of x. So can you have an asymptote there? Can you land on vertical asymptotes? Well, guess what, guys? You cannot land on vertical asymptotes, so this one is false. So even though, yes, I started at when time was 0 and I don't have any negative values, I don't really have an asymptote here since I do start there, okay? So now let's move on to the next one. If there's a horizontal asymptote, it occurs at what? So this would be a y equals something. Well, if you notice this graph, it kind of looks like it tapers off here. And if you remember with Newton's law of cooling, something can keep decreasing its temperature until it reaches whatever the room temperature is. And in this case, it looks like the room temperature is approximately 30. So it's going to be, your horizontal asymptote will be at u equals 30. Okay, and u of t represents exponential blank. Okay, so is it increasing in temperature or decreasing in temperature? Well, since I'm decreasing, it's going to be a exponential decay. If my temperature was increasing, it would be exponential growth. Okay, so in this case, it's exponential decay. The problem situations domain is blank. Well, if I'm starting at u, or sorry, at when I'm looking at my domain, so if I start with my domain, it starts at 0. When x is 0, then it's going to be a bracket 0, and it's going to continue on to infinity. So it should look like this, okay? Again, lots of different versions of the test. You can have any one of these 5 statements, could be true or false. I could change this, I could change this, I can change lots of the numbers. So check your graph, check your numbers, make sure it's all figure out which one you can definitely say was false. All right, what is the domain of the function? So in this case, here's a couple different versions of the same basic equation. Notice the 5s are all the same, natural log, x's. Notice that I have a -4, a +4, and then another -4, but it's outside of the parentheses. Okay, easy thing to do, graph your function. Okay, no matter which version of the test you have, graph your function. You can look at this, let's start with x -4. Let's see, the black one is my first one. You have this asymptote right here where it's at 1, 2, 3, 4. It's at +4. Okay, so that one would be from 4 to infinity because it's increasing. Okay, so this next one is my red graph here, and this time it's at -4, and so I'm at from -4 to infinity. And this one is the blue one, and notice my it's my let's see, my asymptote is at my origin, or so it's going to be 0 to positive infinity. Okay, notice I'm using parentheses each time. Please watch those. Whew. Oh my goodness, this is a long video and I'm getting tired. Let me move on. All right, this is another crazy type of equation. So you have this equation. Notice you don't have a base number at all. It's a variable a. And we also have x, and you have this crazy equation, and you need to find x. Then what does x equal? Okay, well, you're going to have to combine everything because everything has a base of a. Even our function over here has a base of a. If we combine everything here, then we'll know what our x value is, okay? Excuse me. So let's first combine everything. We have a 5 here, and then a minus here. So notice I have 4 squared, so that's going to become 16, and because of the minus, I'm subtracting, but then I'm also adding right here, okay? The way I deal with that is it's all going to be combined. So the 5 is from here, and the 2 times 2 times 2, or 2 cubed, is going to become 8. So I have this. So what that tells me is, because I have a log a and a log a on both sides, and x, it tells me that 5 times 8 divided by 16 equals x, excuse me, let's see, that's going to equal your x, and so, let's see, there we go. I don't want to delete this. I can simplify that, and so I have, that reduces to 5 over 2, and it also reduces to 2.5, okay? So in this case, which one of these is the correct answer? Well, that one's wrong, that one's wrong, that one's wrong. 2.5 is the same thing as 2.5, okay? Let's move on. All right, suppose y varies inversely as the square of x. If y equals 7, then x will equal 4. Find y when x equals 5, okay? So remember our inverse and direct relationships. Okay, so first we need to find our k value. So, first we need to figure out how to set up the equation. So it varies inversely, so I'm dividing, and the square of x, so I'm dividing by x squared. Solve for k, plug your y and your x value in that they give you here, and you're going to multiply both sides by 4 squared, or multiply by 16, and we find out that k equals 112. Okay, so most of you are pretty good at this. It's this next step that you get messed up on. So when they tell you that find y when x equals 5, some of you will actually keep the 7 here and plug it in here, and we'll plug in the 5 squared here, and then leave your k value. I don't know why so many of my students are doing that, but they are. So watch what you replace with what. So here your k is going to be 112, because we found out that's what it equaled. And then we're plugging in 5 squared for x, or 5 for x, and we're squaring it, and solve for y, okay? So that equals that. We are going to reduce it, and we get approximately 4.48. So it would be this answer here. Okay. Let's see, last two, yay. All right, these ones hopefully are pretty easy. We have the square root of e raised to the x power, and we want to select equivalent expressions. It's multiple choice. Okay. Now remember, if you do not have a number here, then you have the root of 2, and with roots, you're going to divide whatever this exponent is by whatever number you have here. So this is going to be the correct answer, e raised to the x over 2 power. Okay, last one, natural log of e squared plus times x cubed. Okay, remember, go ahead and deal with the multiplication here first. Excuse me. Okay, and then deal with your exponents. In this case, this is a little bit more complicated. So you have natural log of e squared plus, because of the multiplication we have plus, natural log of x cubed. Okay, again, exponents go up front of logarithms, and you're multiplying. And then in this case, the natural log and the e cancel out, so you should have 2 plus 3 times the natural log of x. So in that case, this is our correct answer. All right, sorry that this is so long, but I really wanted you to have a great review. Hopefully you are watching it, taking notes, and filling out your index card, and you are ready for the test tomorrow. All right, bye.